So, Chapter 11, Understanding Randomness. Unit 3, Experiments and Surveys. So, this unit basically has to do with being random and also simulations. So, yeah, that's what we're going to go over. So, why be random? Number one, nobody can guess the outcome of an event. Kind of important in some stuff like lottery and stuff like that. Two, when we want things to be fair, usually there's some set of like underlying outcomes that will be equally likely to occur. So, for example, that could be like a coin flip, 50% heads, 50% tail. And statisticians use randomness as a tool instead of a hindrance like some people may think. So pseudo-randomness. This is an important concept because people have a hard time selecting random numbers. So for example, in Mrs. Bakewell's class, we asked the class to pick a number 1 through 4. And everybody did. And statistically, it seems likely that it should be 25% for each one. 25% of people pick 1, 25% of people pick 2, 25% of people pick 3, and so on and so forth. But that did not happen. There was an uneven distribution, and that's because human beings just tend to pick numbers more than other numbers. It's just how it is. And even computers can't even truly are able to create random numbers. They're really just patterns and algorithms that go on and on. So that the quote-unquote random numbers that computer generates are called pseudo-random numbers. So yeah. Next, simulations. Simulations are used to imitate an outcome to find the probability of an event occurring. So that's basically what we're going to go over. We're going to go over how to do a simulation, but first, some vocab. So trial is the sequence of events we want to investigate. A component is the basic building block of a simulation. The response variable is what we are recording in each of our trials. So that's like the y variable in our normal algebraic stuff. Cool. So here are the steps of a simulation. 1, you have to identify the components to be repeated. Second step, explain how you model the component's outcome. 3, explain how you will combine the components to model a trial. 4, state clearly what the response variable is. 5, run several trials. 6, collect and summarize the results of all the trials. And 7, state your conclusion. So those may mean not that much to you right now just looking at them, but we're going to go through each step to show you in an example problem. So here's our example. How many points can we expect from a 60% free throw shooter who shoots 10 free throws? Create and describe a simulation to describe an answer. To determine an answer, my bad. So our first step is to identify the component to be repeated. So in this problem, the guy's shooting free throws. So free throws are the things that's going to be repeated again and again, and we're going to test data off of. So free throws are our component. Next, we have to explain how you will model the component's outcome. So we're going to do this. This is a common setup you can use. So we're going to let 0 to 5 represent free throws that the shooter makes. This is because we know 60%, he makes 60% of his free throws. So that means that 6 out of the 10 numbers, we would have to represent him making the free throw. And since you have to count 0, you only go up to 5. So 0, 1, 2, 3, 4, 5. That's 6 numbers. Cool. Now we have to let 6 through 9 represent free throws that the shooter misses because we need to have the alternative thing there. And in this case, there wasn't any numbers that we didn't use, but let's say in like a lottery one, there's you didn't use 9 or something. You would just have to say that in this step. It's just based off the problem. Okay, next step. Explain how you combine the components to model a trial. So we did this. So I will go through the digits provided and circle each time the shooter makes a free throw and stop once I've tested 10 digits, or in this case, 10 free throws. I will also run through trials for the simulation. So that's basically just outlining what I'm going to do. So let's get to the actual problem now, where we have to, step number 4. I have to state clearly what the response variable is. In my description right here, I said circle each time the shooter makes a free throw. Making free throws, missing free throws, that is our response variable if he makes or misses a free throw. That's what we're recording basically. We're recording every time he makes a free throw, so that's going to be our response variable. Cool, let's get on to it. So on the AP test, they should provide us with a random number set, because if they didn't, we would just be using random numbers calculated or generated from our calculator, which would make it very hard to grade because every single answer would be different, and it would have to be different because it's random. So they normally provide this so the answers are similar. So from here, we're going to run several trials. So I set up trial 1, trial 2, and trial 3. Cool. Now let's just start running trial 1. So we go to the first number to the right of trial 1, 0. Does he make it or miss it? Well, let's look over on our description on the right. Let 0 to 5 represent free throws that the shooter makes. Awesome, he makes it. So we'll circle it. Boom. 9. Does he make it? No. Oh, he doesn't make it. 0. Okay, 1. He makes it. Boom. 6. No. 9. No. 0. Yes. 1. Yes. 7. No. 4. Yes. 6. Yes. Oh, I meant no. 6. No. I lied. I'm sorry about that. Okay, now we stop. Stop sign. Cool. Because that is 10 digits. We said in our description to the bottom right, I will stop once I have touched 10 digits. Awesome. So that's 10 right there. We're stopping there. That's our stopping point. Put that there so that we remember. Cool. Let's go to trial 2. 9. No. 6. No. 4. Yes. 3. Yes. 3. Yes. 6. No. 7. No. 7. No. 3. Yes. 2. Yes. Awesome. Stop there. Stop sign. Boom. Let's go to the third trial now. Same thing. 0. Yes. 4. Yes. 6. No. 0. Yes. 8. No. 2. Yes. 3. Yes. 5. Yes. 1. Yes. 1. Yes. Boom. Stop. Stop sign. Awesome. At this point, we ran several trials. Now we just have to collect and summarize the results of our trials. So basically, we just have to count the circles and divide by 10 and get the percentages. So I did that. Boom. Right here. So the first trial, 5 out of 10. So 50%. He made 50% of his free throws. Second trial, 5 out of 10 again. So 50% of his free throws. Third trial, 8 out of 10. 80% of his free throws. Or her free throws, I guess. So now, we got that. All of our data is done. Now, we just basically have to state our conclusion. So, boom. So, based on the simulation, we estimate that the free throw shooter will make at least 5 free throws out of the 10, or 50% of the time. So, when you're stating your conclusion, you always want to say based on the simulation. That is like a must because it is not absolutely what is going to happen. It's just an estimate. And then I like to at least put the at least 5 free throws because you know that will happen based off your simulation. You can't say anything about the 80% because that did not happen every time. But the 50%, it was at least 50% every single simulation did. So yeah, I would just make sure to put based on the simulation, and yep, that's pretty much it. I have 2 practice problems on a worksheet, and that's about it. So yeah, I hope you guys have a good day. If you have any questions, come talk to me. I'm Ben. This is Ben Tholen, by the way. I don't know if you guys caught that or not, but yeah. Okay.